All right, guys, back with me again. So in this video, in this content, I'll try to discuss about an equations of ideal gases. Yeah. So as we know that the formula of ideal gases is the pressure multiplied by its volume over temperature is a constant one. As usual, you can try to download this file through the link that I put it on the description box below. Yeah. So the first questions, yeah. Scientific balloons are tested in a lab, yeah, before they are used. In the first test, the pressure of the air inside the balloon is 120 kPa. K it stands for kilopascal, yeah. The balloon is sealed and has a volume of 92 meter cube, yeah. The pressure of air inside of the balloon is reduced to 64 kPa by reducing the external air pressure. Yeah. Calculate the new volume of the balloon. Yeah. So we have to rearrange and or substitute into given formula. Yeah. So this is the formula, right? Sasha, you hear me?
Yes, I kind of.
Yeah. In this case, we assume that the temperature is a constant one. Yeah. So it's a constant temperature here. Constant temperature, yeah. So it means that the pressure 1 multiplied with volume 1 is equals to pressure 2 multiplied with volume 2. So in this case, you have to input, yeah, the data from here, yeah. So the pressure is 120, volume is 92. This one is 64 and the volume 2, yeah. That's the equation, yeah. Now
Yes, sir.
you can use, yeah, you can use calculator and I'll get the answers is around 170.
Yes, sir. For me, I go 172.5.
Oh yeah, it's okay. That's okay.
Okay, sir.
It's okay. It's allowed. Yeah, in the mark scheme, it's allowed. I already checked this one. It's okay. Yeah. Give the assumptions that you made in this calculation. We assume that it's a constant temperature. Yeah. Right. A, B. All right. So the pressure now B. Yeah, the pressure of the air in the balloon is returned to 120. Yeah. The temperature of the air inside of the balloon is 290 Kelvin. K stands for Kelvin. Yeah. The balloon is tested again, changing the temperature of the air and keeping the volume of the balloon constant. Explain why the pressure of the air in the balloon decreases when the temperature of air decreases. Right, so for this, I'm gonna write, you can answer like, because it reduces the speed, yeah, speed or kinetic energy in particle. So it means that if you reduce the speed or kinetic energy in the particle, it will have fewer collisions with the wall, yeah, with the container, with the wall or with the container. It means it will have a lesser pressure, yeah, so lesser, the pressure the point is the pressure will decrease, yeah, pressure decrease. That's the explanations for B1, yeah. All right, next. All right, calculate the temperature of the air when the pressure of the air in the balloon is 64 kPa. Yeah, give your answer in Kelvin. Yeah, so I'm gonna write the answer top here. So you substitutions into the given formula, yeah, rearrange. All right, so in this case, I'm gonna zoom out a bit. Yeah, so Here's the pressure over the temperature. We assume that this is now is in the constant volume, yeah, keeping the volume balloon constant, yeah. So it means that the pressure 120, 64, and now this one is 290 Kelvin. This is the second temperature. With cross multiplications, you will get the answer is around 1 Kelvin. That's the answer for number B2. As usual, if you have anything to ask, just drop your questions in the comment section below. Yeah, I'm going to zoom out a bit so you can see the answer for number 1 as whole. Yeah, I mean, as a whole. All right, anything to ask? Number 1, if you don't have anything to ask, we're going to continue with number 2 here.
So the equations, the equation P1 V1 equals P2 V2 is called constant temperature, or is it just like the constant
Oh yeah,
temperature?
yeah. The formula above here, we assume it's a constant temperature, but the formula below right here, we assume that it's a constant volume, right? In the problem, in the word problem already state, yeah. You might try to see. Right, we continue with number 2 here. Number 2, a glass contains fizzy water. Bubbles of carbon dioxide form at the bottom of the glass and rise to the surface. The graph shows the relationship between the volume of bubble and the pressure of the gas in the bubble. Describe the relationship shown by the graph. So as you can see, as the pressure increases, the volume is decreased, right? Or maybe vice versa, yeah?
Are you recording? Or
Oh, no, I'm speaking. But if you want to, okay. As pressure increases, the volume decreases. Or vice versa. As the pressure decreasing, the volume is increased. Now the second one, state the formula linking pressure difference, height, and gravitational field strength and density. So the formula linking three of them is the pressure is equals to depth multiply with the gravitational field strength and the density. So with this formula, we can answer this, the third one, yeah? So the pressure, calculate the pressure difference at the bottom of the glass due to the fizzy water, right? So the depth is 22 centimeter, you have to change into meter. The gravitational field strength we assume as 10 meter per second square, and the density is this amount, as you can see. And I'll get the pressure is 2,400 Pascal. That's the answer for number 2.
okay, sir.
Okay, we are going to continue with this one. A force called upthrust acts vertical upwards on the bubble. When the bubble is released, it accelerates vertically upwards. Draw 2 label arrows on the diagrams to show the forces on the bubble as it is released. So the first, that every object has its amount of mass. It means they have its amount of weight. Yeah, so this is the weight and the upthrust force. Yeah, so this is the upthrust force. Yeah, U or upthrust. Right, so this is the 2 label arrow, right? As you can see, the upthrust force is much longer diagram compared to the weight. It's because that the bubble, as it releases, it goes vertically upward. So it means that the force going up is much more larger than the weight. Yeah, so we can write up thrust is larger than the weight itself. That's the answer for B here. So for answering these questions, we have to know the answer for number 4 here. Yeah, calculate the pressure of the gas in the bubble when the bubble is at the bottom of the glass. Okay, so it means that if you release the bubble right here, the bubble start from a smaller volume, and it here is increasing the volume, right? So just like this. It's because that here the pressure is greater, yeah, in the apa ya, in depth, yeah. So it means if you have any atmospheric pressure is around this here, so it means that the pressure of the bubble at the bottom of the glass is much larger than this. So 101,000 Pascal is plus with the calculate pressure difference, yeah, that we get earlier before is 2,400. So it means that 103,400 Pascal is the amount of pressure, yeah, of the bubble at the bottom. Now, if you already calculate this, we can calculate number 5, yeah. So we assume that here is the temperature of the gas remains constant. So it means that this, yeah. So the first pressure is, you can assume that it's at the bottom. If you want at the bottom, here is 103,400, and this is the volume. Now this is the pressure at the top. The volume of the top is 0.084. Yeah, from this part. So we can calculate, and the answer is this. So we prove that at the bottom, the gas or the bubble has a smaller volume due to the increases of the pressure.